Welcome to CX1104 6.2.1 Orthogonality. In this subsection, we'll talk about the definition of orthogonality. We say that two vectors in Rn, U and V, are orthogonal when their dot product is equals to 0. In the event that one of the vector is a zero vector, that means all element is 0, then we'll still say that this vector is orthogonal to every vector in Rn. So what does this mean when we say the dot product is 0? Well, when the dot product is 0, the numerator of this expression is 0. The norm of the vectors are not 0 if we assume that u and v's are not 0 vector, and hence we are doing inverse cosine of 0. And this happens when theta is equals to the 90 degrees, or sometimes we prefer to do it in radian, pi over 2 radian. What does two vectors with 90 degrees angle means? Well, when theta equals to 90 degrees, basically it means that this is the right angle. So in the 2D world, when two vectors are pointing at 90 degrees away from each other, then they are orthogonal. In here, we have I going along the x direction and j going along the y direction, and they are 90 degrees. Actually, minus j is also orthogonal to I. You will also learn that in the ij definition, these are called the standard unit vectors of R2, where the values of I is 1 unit along the x direction, 0 unit along the y direction, and for j, it is 0 unit along the x direction and 1 unit along the y direction. This R2 to R3 world extends naturally when we have R3. In this case, we still have I, j, and now we have k. In addition, I is now an R3 vector, means that it has 3 elements: x-axis, y-axis, and the z-axis. And as before, for the standard basis or the standard unit vector, each of these I, j, and k only have 1 in one of the axes. And if we now examine this question 1b, and its solution, it asks us to show that the standard basis for R3, I, j, and k vectors are orthogonal. What we do simply is using dot product of I and j, I and k, j and k, and we show that all these dot products between these standard vectors are 0, and hence the 3 vectors are orthogonal with respect to each other. So this is the working over here. So let's repeat the idea of orthogonality. When two vectors are orthogonal, it means that the angle between them is 90 degrees. In other words, the dot product between them is 0.